Okay, this is the same section, the problem number 15. Yes, so we're going to solve this linear system using the substitution method. Again, looking at these four parts on the left side of the equation, you want to find the easiest one to be isolated. Which one is that? It's the one that is standing alone without any coefficient in front, right? Well, this is kind of obvious. This guy, again, right? So let's isolate this. Well, you could isolate, other variables and still get the same answer, but it will introduce unnecessary complication because you have to, for example, if you want to isolate 3y and solve for y, you got to divide the whole equation by 3. That will produce fractions, right? We don't want that. We want to make the calculation as simple as possible, right? Avoiding, fractions or decimals. So that's why. So equation 1 is now transformed to x equals 16 minus 3y because we were isolating this x by moving the other piece, 3y, to the other side. Again, the sign in front of 3y flips from positive to negative, okay, when going over the bridge. Okay, 16 minus 3y is equal to dx, right? Now we're going to bring the other equation down here, right? For x minus 2y is negative 20, right? Again, you see that this second equation contains the same variable. It shares the same variable x here, right? So this x in the second equation can be replaced by the x expressed in terms of y from the first equation. Okay, I call it 1 prime because it's derived from the first equation. Okay, so this x will go in here, or this thing, 16 minus 3y goes in here in the second equation. Now what does the second equation look like after replacement or after substitution? Okay, this x itself is now in the parentheses 16 minus 3y. Now it looks like we're making the calculation more complicated, but no, we're reducing the number of variables in one equation from 2 to 1. Okay, so let's write out all the rest parts of the equation 2. This one, right? Yeah, equation 2 has transformed from this shape to this shape after plugging in the equation 1 prime into x. Okay, now we see only y in this single equation, so you can solve for y. Okay, let's do the same thing. The distribution of 4 over 2 terms. 4 times 16 is 24, 64. Yep. And minus 12y minus 2y goes negative 20. Right? And then let's combine these like terms. Okay, so it's a negative 14y because negative 20. Then moving this constant to the other side, you get this thing, right? Negative 84. Negative 84. So let's solve y by dividing both sides of the equation by negative 14. I think I get, how much is that? 6? Yeah, negative 84 over negative 14. You can use a calculator, but I think it's 6. Yeah, 6 positive, because you're dividing a negative number by a negative number, right? So the sign, cancel out. Okay, so we've found that one of the variable y turned out to be 6. Okay, so let's find x, the other one, using equation 1 prime, because 1 prime is written in terms of x equals something, so it's very useful to find x. Entering y equals 6 into 1 prime, your x becomes 16 minus 3 times y, but our y is now 6, right? We've found that it's supposed to be 6. Okay, so 16 minus 3 times 6 is 18. It's negative 12, negative 2. Yeah, negative 2. So that's it. The answer is negative 2 and 6. Okay.